Alright, hello class. This is Math 1430, section 3.3, the chain rule. I'm just going to do one example. And again, you can watch WebAssign video as well, the WebAssign video. And of course, my lecture notes on Learn, which would be under course announcemts. Okay, so given this function, f of x equals 3 times the expression 3x squared plus 6x plus 4, we want to find the derivative, f prime of x. So the main thing to look at is right here. This is a composite function because you got an inside part and then you got the exponent, which is the outside part. So you're really composing two functions here. So whenever you see something complicated like that, the derivative is going to involve the chain rule. Okay, so here we go. I'm going to write f prime of x is equal to, this is a constant factor, this 3. So I'm just going to pull that out. I'm going to show all my work here by going, it's going to be 3 times. And then I'm just going to write d dx, just to say I'm going to take the derivative of the 3x squared plus 6x to the 4th. So this is just kind of showing work, just so you know what's going on. You don't have to show this step if you don't want to. So I got f prime of x, the derivative is the same thing as pulling out this constant factor 3, because that gets involved in your answer, times the derivative of that expression. Okay, so proceeding, this derivative is now going to be 3 times, and now let's take the derivative of this expression. So here's how the chain rule works. We're gonna take the derivative of the outside part, evaluate it at this inside part, and then times the derivative of the inside part. So the first step is to bring down this 4 out front, kind of like the power rule. So it's going to be 4 times, keep the inside exactly as you see it, 3x squared plus 6x. And then what's going to happen to this exponent that was a 4? By the power rule, as you know, you get decreased by 1. So that's the beginning part. We took the derivative of the outside part, evaluated at the inside part, and now by the chain rule, we got to go times the derivative of the inside part. So if I wanted to, I could write times d dx of this, but I'm just going to do it directly. What is the derivative of this inside part, the expression in the parentheses? So we're going to use the sum rule here. So just go derivative plus derivative. So the derivative of the 3x squared, let's write parentheses here because this is going to be an expression. Remember, all expressions have to go in parentheses. So the derivative of this inside part is going to be, you bring down the 2, 2 times 3 is 6x to the first, which is just 6x, plus, and then the derivative of 6x is just 6. So let's just write 6x plus 6. Okay. And now let's just simplify. So this is going to equal, so I know the 3 times the 4 is just 12. And then I'm going to write down everything else I see. 3x squared plus 6x cubed times the 6x plus 6. So that's what we have so far. I multiply the 3. And these are all factors, so there's no distributive property here. So 3 times 4 is 12, and then that gets multiplied by that. Okay, so, normally I would accept this as a final answer, but I do notice I can pull out a 6 here, because that's the GCF for this factor. So let me do that. So now we've got equals 12 times the 3x squared plus 6x all cubed. And then if I pull out a 6, I'm going to write times 6 times. When I pull out the 6, the GCF, I'm left with x plus 1. It's always nice to simplify when you can. And then I'm going to multiply the 12 by the 6 there. So 12 times 6, these are all factors you can multiply in any order, is 72. So I'll write 72, and then we got the 3x squared plus 6x cubed. And now just the x plus 1. And I'm going to stop right there. I think that's good enough just like that. Let's see, make sure everything looks good here for a second. I don't want to make any mistakes here. So let's kind of review what we have here. So to take the derivative, we first pulled out this constant factor because you're allowed to do that by property of derivatives. So the derivative is just going to be 3 times the derivative of the 3x squared plus 6x to the 4th. And then to do that derivative, the chain rule is going to be required because this is a composite function. So it's going to be 3 times, and then you bring down the 4, this 3x squared plus 6x, decrease the power by 1, and then very important, times the derivative of the inside part. So the derivative of the inside part, this is the inside part right here. So the derivative would be 6x plus the 6, and then I multiply 3 by 4 to get 12, and then we got the 3x squared plus 6x cubed times 6x plus 6. Try not to make transcription errors. It's very easy to you have the 3 correctly here, but then it's easy to, forget about the 3. It's easy to make an omission like that. So, it's always good to check your work like I'm doing now. So that looks good. And then, yeah, see, look at that. I did make an error coming up. So I got 12 times 3x squared plus 6x cubed, and then that third factor, I pulled out a GCF of 6. So now you're left with 6 times x plus 1. And then 12 times 6 is 72. But look at this. Here's the exponent 3. See, those 3's are all correct. And then mysteriously, I forgot to put it down here. So that's a transcription error. So don't do that like I almost did. It's very important to check your work. Now the answer looks correct. So, oh, wait a second. Almost. See, I put the 3 mistakenly here. See, this 3 doesn't go there. It goes there. So it's good that I made a mistake just to show you that it's easy to do with these chain rules. It gets confusing with all these exponents and bringing them down every time. So just take the time to make sure everything looks kosher. And now I believe that's a final answer. 72 times 3x squared plus 6x cubed times the x plus 1. Yeah, I would stop there. I mean, because this is a cube, I wouldn't bother pulling things out. It gets a little confusing. So that's good enough just like that. All right. So happy Labor Day weekend, everyone. And I think it's Labor Day. All right. So we'll talk to you all later.